several ways we could do this. That's one way. The other way, this way you need to first set the degree yourself. This way you give the degree, then first thing set the degree, then you allocate the memory, then for or to initialize the polynomial, and p dot coefs Okay, so that works with n equals -1. Print poly doesn't use that. How did we do it? So alloc poly, you give it a degree. So to show how that would work, you'd say passing the address of sum, and then that degree that you want. You need that. That's the point. See these two lines. This one, oh, got minus 1. I think in mathematics it's not minus 1 that is used, it's minus infinity, but we don't have minus infinity, so could just do it like that, or you could say like that. The reason you use minus infinity is exactly that when you add minus infinity to minus infinity, you get minus infinity. That is what is going on. Here, you see this initialized business. Don't need that. You can just say init poly prod like that. See, now it's arguably clear what's going on. It's not always the case that by introducing more functions you make things clearer. But if you get used to the idea that many things can be allocated and initialized in their own specific way, and you always put the same name for that, you can save a few bugs from coming into your code. Okay, now let's derive a polynomial. If p dot n is smaller or equal to 1 to 0, which means that the polynomial is a constant, then derivative of a constant is just 0. Otherwise, it's going to look something like you have constant, linear, quadratic term, right? And maybe cubic. Then you derive, the constant goes away, right? The linear term, so this is d, goes away. C times x just becomes c. B times x squared becomes 2b. And a times x cubed becomes 3a, right? And you can put a 1 here. There's nothing here. So it's relatively straightforward to see what's going on. Alloc poly p dot n minus 1. Alright, so you reduce the degree by 1. And then for I equals 0, I smaller or equal to dir dot n, I plus plus. Actually, let us start at 1. So we loop from 1 to n minus 1. So the first element is going to be dir, not coef, I minus 1. It's going to be 1 times the coefficient at position 1 in P. You see, we know that P dot n is at least 1